This is called applications of quadratic functions. Like a lot of lessons, they're all applications of quadratic. But this one specifically is like, let's take our new skill at completing the square and take it for a test ride. So it's like 50% reviewing how to complete the square and 50% what are we doing with this thing. Now that I've said that, there are some word problems in this section, which should scare you this time if the equation's not given. If the equation's given, you should be bored. Okay? You should be bored. But if the equation's not given, the game is on. Okay? So we'll get to that in a minute. For now, let's review what we know from yesterday's lesson. Complete the square to convert from standard form to vertex form. When there's no a value, well, that's a lie. It's not that there's no a value. When the a value is 1, when it's just x squared, I hope you practiced that and went, well, I can do that. I can handle that. When there's an a value out front, that's not 1. And there is, right here, there's -1, and over here there's a 6. And I'm actually going to skip to part B. I'm going to do B first, because I think, even though that's a 6, this is the easier one to see, okay? At least to see the first step anyways. The whole yesterday's lesson was, oh, you can complete the square? Yes, we can. What if there's an a out front? I don't know what to do. Teacher says, okay, what we're going to do then is we're going to common factor that 6 off just the first 2 terms. And notice I put the plus 65 over there, just like I did in the regular complete the square lesson one. It's not going to be the right number anyway. It's not going to be the perfect number anyways. I mean, it could be. 1 in a million chance it's actually the right number for what we want to accomplish here, but usually it isn't. So move it out of the way and say, no, I'm just going to move that over there. I'm not going to worry about it to the end. It'll be in the question. It'll always be there. I'm going to move it over there. Well, if you get that, actually, it's not too bad. Now we are going to complete the square. See, now inside the brackets, the a value is 1. Good, fixed. There's one little thing at the end, that's all now. I'm trying to make it sound easy, yeah? Because there's a lot of steps involved here. Then I do my magic number, which hopefully you're good at. And this is the part I was talking about that I hope you did enough homework that you're totally ready for this. You know what the magic number is, and you know what to do with it. If you're not there, it's time to panic. Yes, it's time to get a bunch of your weekend to getting this figured out. If you know this answer, well, then you're pretty happy. What's the magic number? +4 and then subtract 4. He's got it. If you're with him there, you can take the panic level down and go, yep, there's things to learn, but I'm okay, as long as I know that's what I got to do. How did he get the +4 and the -4? How did he come up with those numbers? What's the system? Yeah, we're learning that having labels for these numbers, A, B, and C, at first was confusing and now is sort of helpful, so we can point them out and say, the B. We're taking B and we're dividing it by 2, and then we're squaring it. So the B here is -4, and when I divide that by 2, I get -2, and then when I square that, I get 4. That's the magic number. And by magic, I mean, it might seem weird that we chose that number. Now, am I allowed to just add 4? I want 4 in the question. No. You can only add 0. So if you add 4, you've got to subtract 4 as well. The next step is the same as regular complete square. Factor the trinomial that you've built, and you're in for a surprise. Well, maybe you're not surprised. Maybe you're like, I know what's going to happen here. It's so good. What 2 numbers multiply to +4, but add to -4? -2. And you hear how she said it? She said -2. She didn't say -2 and -2. She didn't say -2 twice. She said it's -2. That indicates to me she sort of knows where this is going. It's -2 and then -2 again. So maybe you're at the point where you're actually writing that. You're jumping right to there. You're not writing x minus 2 and another x minus 2. Maybe not. Maybe you need that step. I like the step if you need it. But you're writing x minus 2 with a squared there. All of that is pretty nice. Here's the step people miss and forget. Grade 10s, grade 11s, grade 12s, all through your life. I encourage you to bring back the arrows. This 6 has to get multiplied by this stuff, but it also has to get multiplied by that -4 that's out there. That's an easy mistake to make and will happen again and again. Draw the arrows like for the rest of your life. Not like, oh, until I am good at this. No, I think forever. Draw that arrow in this case because it's easy to miss that. So I wrote that in red. I want to switch back to green, and then I get negative 24 plus 65, and I'm almost done. Just combine the negative 24 and the 65 to get positive 41. Two important things to tell you about. One, a good question, and Mr. Yakimishin said it came up yesterday. The good question is, why don't you have to multiply the 6 by the negative 2? And the answer is, you do. If you pulled this thing apart and went x minus 2 times x minus 2, you'd eventually multiply by the 6, but we don't want to do that because then it wouldn't be in vertex form. So you absolutely have to do that if you're going to get rid of these brackets. The second thing is, how am I going to check this? I say sub in a clever number. I can think of two clever numbers to sub in. 0 is the first one. Sub in 0 to this one, answer 65. Sub in 0 to this one, okay, that takes another second. 0 minus 2 is negative 2, squared is 4, times 6 is 24, plus 41 is 65. Does that mean for sure it's right? No, but it makes you feel a whole lot better that you didn't miss a step. What's the other clever number that you could sub into both these that would work very well? 1 would work very well because 1's always easy to sub in, so that's another good choice. There's another really clever choice that makes subbing into one of these really straightforward. 2. Look how easy it is to sub 2 into this second equation, because 2 minus 2 is 0. Bang, answer 41. Then I got to sub 2 in this, and that's a little more difficult. But I think 0, 1, and 2, those are the ones you could sub in to check if you're like, I feel like I might have made a mistake here, and I don't have the back of the book to check or anything like that. Well, this is supposed to be easy after that. The blank value of y is 41 when x equals positive 2. We did good at that changing sign on the test. Only a couple people got stuck a couple times and put the wrong sign there. And is it a max value or is it a min value? Is it, okay, so, okay, which way does this open? Positive a value. Wait, what? I know. We're at the point now, and if you're annoyed by this, my asking that, I know what's happening. You're now juggling a lot of balls. Yeah? You got a lot going on here in quadratics, a lot to keep track of, and now I'm suddenly going, hey, what about this one over here? You're like, ugh. She's confident. She says minimum. Why is it a minimum? It opens upwards. And I think you're doing good when in the middle of one of these questions you just draw something over here to go, what are we talking about here? We're talking about one of these. So this is a minimum value. And I asked that question on purpose because in the word problems that are coming, we better be able to think about whether we're looking for a maximum or a minimum. All right, this one's so easy, it's hard. We don't do enough of these ones where it's just negative 1 up front. But I promise it's actually the exact same steps that I just did, but it looks weird and it's odd looking, okay? So this one is not a value 1, so I have to do that common factoring trick. Common factor the negative, or you can think of it as negative 1, off of that first two terms. So I'm pulling the negative out front, and I get x squared plus 12x. And I encourage you to write the negative 17 off to the side. It's like a mental trigger going, I know 17, I'm aware. I haven't forgot about you minus 17. You'll have your moment in the sun, but it's not now. For now, I got to do a little work over here with the a's and the b's. And here's the key moment from the first lesson of the chapter. Do you know what to do now that the a value is down to 1 again? I've taken the a value out of it. What's the magic number and how do I get it? $36, she got it very quickly. I didn't even see her write down anything. Did you write down something or are you way ahead of me? I'm dying to know where she's at. Now, she's at the point I was like, I can just do it, right? I know what to do here. Divided by 2 and squared. Take the 12 divided by 2 and squared. But don't be ashamed if you have to go over here and go, b over 2 squared equal, I'll write a little smiley face on your test if over on the side it says this. Okay, here's me writing, yay, good for you. Great stuff. That's the key to completing the square right there. Everything else is management, but that's the key, is to know that 36 is the magic number. So am I allowed to just add 36 to things? No, you can't just add 36. That will change the equation. So there's a price to pay. You want 36? You got to write subtract 36. And just draw a line down there so we don't get the two sets of algebra confused here. Then I do it every time I underline the trinomial that I've created. And hopefully you're not surprised now. The two numbers that multiply to 36 and add to 12 are 6 and 6. They're both 6. So I get this. S squared? You have a question or a correction? Oh. She's going to do the question. Somebody else has to do the correction. Tim's going to, you got the correction? He thinks so. Okay, your question. You're talking about these two, the 36 and negative 36? No, because it can't get in there. Unless I'm going to expand it out, that negative can't get in there. I common factor the negative out, and that made everything inside positive. So I was working with positives after I common factored that negative. Do you see that? Started with a negative, and then went to positive. But I bring you back to the calculus saying we have. And these are advanced calculus students battling with crazy algebra every day, and still we have a saying, it's always a negative. You know? They come back and they do all this crazy algebra, and then they find one little negative. Oh, it's the negative. You know? So managing those negatives will always be a challenge. Tim, you got the correction? Tell me, what's the correction? It's plus 36. It's going to drive you nuts, friends. Yeah? That's why you paid me to show up today, was to make a big deal out of this and dramatize it so that you remember to draw that arrow. I don't mean like draw the arrow until you get good at it. No, not this time. Not like b over 2 squared was like, I'm so good at it, I don't need to write your b over 2 squared over there. Maybe you can get that good. But nobody, I mean nobody that I know of shouldn't write that arrow in there to remind themselves to distribute the negative back in. You common factored it out. You've got to multiply it back in when the time comes. Tim. Tell me about it. Yes? Yeah, I like it. Yeah, two sets of brackets. I didn't know what to do. I've often done it with two sets of brackets and square brackets. I worry that that confuses some people. So maybe this works out good. He showed you one way, and if you like his way of handling the brackets, so do I. So do I. But if you are like this sort of makes it so that all these brackets aren't around. So this might be another way for people to think about it, but I don't like one over the other. It wouldn't surprise me. If you look at my, next year if you're in my grade 11 class, the video on there, I probably use both brackets on there because I'm just trying to catch everybody here. Good, I'm glad you told me that. So then, one last line. And what's the magic check numbers? If you want to check this quickly. Oh yeah, sorry, I didn't. We talked about it and then I didn't fix it. Got distracted. Plus 36, thank you. Whoa. Mr. Yak made my eraser giant. Did he make some big mistakes? Is that why? That's just a joke. There used to be, every second kid in my class had, for Christmas, they get this giant eraser. And it said, for really big mistakes on it. Everybody had one. Have you ever seen one of these? Yeah, when I was a kid, everybody had one of these. It was the coolest Christmas gift ever. It's just a giant eraser. Plus 19. Would I have caught it with my check? Actually, now I wish you hadn't have told me I made that mistake, because I would have caught it with my check. We would have, oh, that check's really good. What's a good number to sub in to check this thing? 0, always good, right? If I put in 0 to this one, I get negative 17. If I put 0 into this one, I get 36, negative 36 plus. Yeah, negative 17. I'm not saying you should do it as fast as me, but that's what you type in. Sub in 0. Or -6, but -6 isn't quite as good. Yeah, but both of those would be good. Yeah. So the blank value, I'll get to that, of y is 19 when x equals -6. That one in the brackets is always the opposite for some stupid reason. Is this a max or a min? Max. And again, I encourage you to do this either in your brain or off to the side to go, hey, this is a downward opening parabola. This will be a maximum value. Do you have questions? I got to keep rolling. Mrs. Todd just did this lesson in the other class, and she told me it went right to the bell. That doesn't work as well. If you want a quick check, I think the two magic numbers to check are sub in x equals 0 into both these, because subbing in 0 is always pretty easy. 1 was a good suggestion. And then this, see this is +6. If you sub in -6 to both, that's fairly good too. But I still think 0 wins. I think 0 is the one to Euro use. Okay. Questions there? All right. Word problem tips. No, you know me. I'll come back to the instructions at the end. Let's see if I use the instructions. Let's just do some mathematics, and then we'll come back and see if this recipe is a good one, if we like it or if we want to modify it, okay? The trajectory of a T-shirt shot out of a T-shirt launcher. Do they still do this at games? You go to a baseball or a basketball game, and they got a T-shirt shoot, and they boom, 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 and they shoot them up into the crowd, and if you're lucky enough to catch one, you get a souvenir T-shirt. It's pretty cool. Yeah, I know, this is the problem, and I'm not complaining about this world, but one person gets hurt somewhere, falls, and then now they don't do it anywhere. But anyways, you don't know what I'm talking about, though. They used to have these T-shirt shotgun things that they shot up into the crowd. Just a parabola. Anything flying through the, I could have said anything here. Anything flying through the air follows a parabola. For reals. Can we modify this equation? Okay. New feature. Here's another reason you paid me to come in today. To let you know that from here on in, if they give you the equation, you should write a little smiley face over it. You should be like, yes, this won't be so bad. If they give you the equation, it's going to be okay. That's sort of foreshadowing. Hopefully you're like, you're not going to give me the equation every time? Yeah, well, that's what this lesson's really about. The rest of this is just warm up. I'm warming up for the first question where the equation isn't given. Get ready. Get ready. Equation given. If you're caught up in your algebra, this should be pretty straightforward. It says, what did the height of the T-shirt start at? Which of my weapons? I look through my tool belt and go, what's that?
Probably 0.
0, he says. If it's start at, what time are we talking about? 0. This is find the y-intercept. This is just the application of finding y-intercept. So for A, set t equals 0 for initial height. I wrote that whole sentence because I'm the teacher, and when you look back at this, I want you to see. So if it asks for initial height or initial profit or initial cost or initial anything, you go, oh, initial, starting, t equals 0. That should be an easy sub, and he's so right about this. In this particular question, when I sub in 0, I'm going to go through the procedure there, but it's 0 plus 0, which is 0. What height did the T-shirt start at? The T-shirt started at 0 meters. They don't always start at 0. This one happened to start at 0. Must have been a cannon on the ground, yes? They must not have been holding it in the air. Must have set it down in the infield, dropped the shirt in, boom.
Maybe they were below sea level.
Maybe they were standing below sea level, making the height, initial height it is, right? So true. All right, determine the maximum height and when it occurred. Here's you, here's your brain. Boop, boop, boop. Boop, 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 boop. Max height. Sound effects. Yeah? I wonder what that'll sound like on 1.5 speed. That. noise. What feature of the parabola will I need to find the vertex? Okay, that's the way your brain is supposed to go here. As soon as it says max height, you go, oh, vertex. Next question. If I want the vertex and this equation's in standard form, what form do I want to get? I want to get the vertex form. And now the question of the day. The question of the day. What is the procedure called to get a quadratic from standard form to vertex form in a reasonable amount of time? Not like last chapter. Remember last chapter was find the zeros, add them together and divide by 2, sub that in. No. We've got something else. To put it into vertex form in a reasonable amount of steps. What's it called? We want the max, but what's the procedure called? Math. That's technically correct. Okay. You get a little sticker instead of a big sticker. He caught me on a technicality. Did you hear what he said? What's the procedure called? He said math. Technically, the question is what class are you going to? Completing the square. Best phrase of the semester, I argue. What did you learn to do this semester? Complete the square. Yeah, complete the square. So that's what I'm going to do. I'm going to take this one. I'm going to complete the square. Here's the procedure. A little faster, because you've had your lesson yesterday on it. I'm going to talk about all the steps. I'm just going to go a little faster now. Because we had your lesson yesterday, and then I've done 2 full examples for you. The procedure looks like this. Common factor off the a value. Take the -5 out of there, giving me a nice quadratic that has a value 1. That's the whole deal yesterday. I'm sure he did a great job. What did he teach for like 45 minutes or an hour? Basically, he came in and said, hey, just common factor the a out. That's basically the whole deal. Common factor the a out, so now it's -5. Yeah, that's right. Then, now you're set. Now you go back and do what you already know how to do. b over 2 squared, what's -10 divided by 2? -5. Square it. Squared, yeah, 25. Add and subtract that number. Allah, yes? -10 divided by 2 squared. Yeah? Underline that trinomial you've built. Amaze yourself by what happens. 2 numbers that multiply to 25 and add to -10. It's -5. Look, it's right over there in the brackets. Yeah, you went through the procedure and found it. So h equals -5 t minus 5 squared. Heavy drama. Heavy drama. For a sticker, what am I about to draw? The arrow. The arrow. Listen, that was so good. I'm going to go get an R2-D2 for you.
Can I put it on my phone case?
Do it. Careful. Don't damage R2. It'll be like, whee! Can anyone do the R2 noise?
He's never watched that.
He never.
I've seen a little bit. I've never finished the movie. He's never watched Back to the Future.
This makes me sad. The arrow. Oh, Mr. Todd, I'm good at algebra. I don't need the arrow.
Yes, you do.
Aren't you cute with your I'm good at algebra statements? Todd, don't laugh at me. I'm not laughing until you don't put the arrow on and you get this wrong. Then I'll put a little LOL at the side. Ha 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 ha. You didn't listen to your Mr. Todd. Here, you try. Write the vertex, and then write the therefore statement. We want the maximum height and when it occurred. I think we're home free now. Write the vertex, then your therefore statement, and then I'll do it in a minute. In a minute, I need a cinnamon bun. Cinnamon buns? I went and picked up one of these to try to eat healthy. No, it doesn't look so good. Yeah. Oh no. Bathing suit season's coming. What? That's good. What? It's angry. Therefore, the max height is 125 at 5 units. Units? Meters. Seconds. You are happy? Todd, this complete the square stuff actually does things. Actually does things, yes. Can actually find the apex, the vertex, the max. Oh, yeah, good question. I'll put it on there. Why is it positive 5? Right there. We get it from here, but we have to, oops, don't be like that. But the one in the brackets, we switch the sign, yeah, because it moved right 5. Yeah. Okay, you're happy? You're happy? It's okay, I'm here to fix that. No, thank you. On a Friday. Ms. Todd, there's no equation. There's no equation. There's no equation. You jerk. 32. Yeah. No, I agree. I'm quite willing this time to go, okay, we are sad. No. We switch from sad to focused. We're like, okay, here we go. I have bad news. The word problems in this chapter are very difficult. The good news is they're also very repetitive. So if you go into the homework and you do them like, oh, here's another one like that, here's another one like that. Okay? To motivate this question, it says find two numbers whose sum is 32 and product is the minimum. I'm going to do this with math, but not with quadratics at all. And by the end, hopefully I'll convince you of a few things about this problem. New flip chart. Yes? And for you, if you're going to copy this down, you might want a separate sheet of paper. Yes? Or maybe you're just going to follow along and go, yeah, that's very interesting. Two numbers whose sum's 32. Second number. And whose, what did it say? Product. In a minute, we're going to need someone to tell us what product is. Maybe you don't remember. Anyways, first number. Here's my, I call it a systematic approach. I'm going to get the answer. I say, what happens if the first number is 1? I'll start with the number 1. If 1's the first number and the sum is 32, what's the second number? 31. Oh, yeah, no, we are. Hey, oh, no, he's multiplying. I see what he's doing. I'm just dealing with the sum for now. There's two numbers whose sum is 32. Now, what's their product? 31, because product is multiply them together, okay? Ooh, got to know. Product means multiply. I'm trying to maximize the product. I'm trying to get the most product I can. The next number I'm going to try is 2. What's the second number if their sum is 32? Sum.
Oh,
30, good. Then what would their product be? 60. That got bigger. I'm looking for the maximum. This is good. It's got bigger. What's that? Find two numbers and its product is a minimum. That's incorrect, by the way, in the note. It's a maximum we're going to find here. Yes? That is incorrect in the note. I'm sure there's a correction somewhere, and maybe it was me that missed the correction. How this works with teachers is we make up files, we send them back and forth, everybody uses them back and forth around, and often there's a little mistake in it. I probably didn't catch the mistake that was sent. What's the next number I'm going to try? 3. What's this one going to be? 29. How are we getting that, by the way? How are you coming up with that second number?
32 minus the number 1.
Yeah, we're doing subtraction actually. This is actually subtraction. So I'm going to start writing that every time just so everybody can follow what I'm doing. Take the 32 and subtract the 3 to get 29. Then multiply those together. 3 times 29? 87. This is going to go on forever. Well, it's going to go on for a long time. There's no question about that. And the first time through this, that's one of the things I want you to see is that if we don't use quadratics, this could take forever. Like if the two numbers added to like 106, we'll be here a long time. I'm going to keep going a little faster. If the first number is 4, what's the second number? Because we went 32 minus the first number, and we got 28. And 4 times 28 is 112. Still getting bigger. Yeah, you're right. We're just going to keep going. I want you to notice something, though, what's happening. From 31 to 60 was a pretty big jump. From 60 to 87 was a pretty big jump. From 87 to 12 was a pretty big jump. But it's going to be a parabola. It's going to start leveling off here eventually. Let me do 4 or 5 in a row to show you what I mean. 5, 32 minus 5 is 27, 135. 6, 32 minus 6 is 26, 156. 7, 32 minus 7 is 25, 175. You see it starting to settle down just a little bit? We've got a long way to go. But the gap between these is dropping off. This isn't going to go on forever. Eventually, I'll get there. Am I going to run out of space before I get there? I don't know. 8. I got to start writing smaller. 32 minus 8, which is 24. 192. 9. 32 minus 9, which is 23. 180 plus 1, 207. 10. 32 minus 10, 22, 220. Let me be transparent, right? I can reach in with a can opener, open my brain up. Here's what I hope is going on here. You're like, I can follow what's happening here, but please tell me this is not what we have to do on these questions. It's 16 to 16, he says. Did you keep going and got it? How'd you know? Huh? Oh, it's the middle. Yes? Okay, yeah, good. It's the middle, but okay. We'll keep going like this because I have another point I want to make about this question here. Coming up, 11, 32 minus 11, 21. 11 times 21 in my head. That's 210. 231? Something like that. 13, 32 minus 13, which is 19. 13 times 19 in my head, it's 57. 247? Still going up? Will this never end? 14. 32 minus 14, which is 18. 14 times 18, 72. 252. Still going up, but not as much. Hey, you see it's settling right down. We're getting to the top of that parabola. The gap between each one is getting smaller. Instead of gaps, it's doing the 1, 3, 5 rule in reverse. Instead of gaps of 9 and 7, it's now 5s and 3s and 1s. I know there's not 5s and 3s and 1s. But okay, 15. 32 minus 15, which is 17. 15 times 17, 50, 85. 235? 255? 16. 32 minus 16. 256. Look at the gap now. And then the next one, 17. 32 minus 17, which is 15, and it goes back to 255, and I've got my answer. 256 is the max. Whew. Now, reach down and flip on your brain power switch, because all of the teaching of this example will actually be in the next 90 seconds. Mr. Todd, I do not want to go through that whole table. I don't want to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And you were actually kind with your number of 32. I need a shortcut. And I know what you're thinking, oh, I'll just do halfway every time. In this particular phrasing, halfway works, but I'm going to tell you that's not normally always how it's going to work out. Here's my move. Let the first number be x. Now we're cooking with gas. Yes? Algebra. If x is the first number, what's the second number? Yeah, what am I looking at? When x was 10, I got the second number by going 32 minus 10. When x was 7, I got the second number by going 32 minus 7. 32 minus x. Go home. Get your stuff and get out of here. That is powerful mathematics. Woo! You know the Iron Man? You didn't watch Star Wars? Nope. You watch Iron Man? Yep. There's a scene where he's fighting that guy with the electricity, and he's got Thor. He was fighting, and Thor goes to the lightning, and he looks and he goes. His power meter goes to 180%. He's like, hey, that's what I just did there. You're like, hey, 32 minus x. If x is the first number and 32 minus x is the second number, what is the product algebraically? And you multiply them. X times 32 minus x. Now we're cooking with gas. Yeah, I already said that, but it's too good a saying. It's perfect. Okay. Do better, Mr. Todd. Okay, here's me doing better. Here's me doing better. Let x equal the first number. I heard someone say y, and I'm going to show that. If you write down y, it's okay. Instead, I'm going to write let 32 minus x be the second number. Okay? And I'm going to try and teach two ways at once, just like we talked about Mr. Yak doing the algebra slightly different than me. Some of you might like this better. You actually go over here and go, therefore, you'll go, let y be the second number. And then you'll write an equation. X plus y equals 32. That's what I know about the two numbers. But then if you solve for y, you'll find out that second number is 32 minus x. I don't say that's better or worse than what I did over there, but it's a different way of thinking about it. Either way, you get your third let statement. Let p equal x times 32 minus x be the product. And what's supposed to happen there is you go from unhappy to focused to now happy. You're like, I've got the equation now. Now it's going to be okay. And we could just find the zeros, add them together. But because it's a complete the square lesson, I'll do complete the square. But I allow you to choose your method to find this. Here's the steps to completing the square to find the vertex. Wait, why am I completing the square to find the vertex? What is it about the question that tells me I better complete the square to find the vertex? Which word in the question tells me complete the square to find the vertex? Yeah, as soon as you see the word maximum, that's supposed to trigger you to go. As soon as you read the question, like maximum, need the vertex, need to complete the square. Okay. A little faster on this because hopefully it's getting a little bit repetitive. Common factor out the negative. Half of 32, 16 squared. Who's got it? What's 16 squared? 256. So that's the magic number I'm going to use. P equals negative x squared minus 32. Oops. Plus 256 minus 256. And let's see if I do it the way Mr. Yak did yesterday. Something like this, probably. Then the arrow, and I get P equals negative x minus 16 squared plus 256. Tim, is that close to what he did?
That's a lot of stuff.
Okay.
How did it become negative?
How did it become negative? Because I common factored out that negative. When I took the negative out front, it was negative 32 in the brackets. Oh, sorry, it was positive 32. Then when I common factored out the negative, it became negative 32. Vertex, 16 comma 256. And my therefore statement. Therefore, we get a maximum product of 256 when x equals 16. Oops. Now here's some wisdom for you. Of the two methods I just showed, which one was better? I think it's a tie. In this particular very easy quadratic question, you're like, very easy. I'm like, yeah, sorry, folks. As things go along, not necessarily in this grade. That might be the hardest question of this grade. But as things go along, quadratics will get very difficult. In this particular question, the algebra isn't a whole lot better than doing it by hand. But it will only go the other way. Algebra will only become more and more advantageous as the situations get more complicated. Good news. Please tell me there's some good news. Yeah. There's only a few types of word problems. That's one of them. You'll see a bunch of those in the homework, in the review. You'll just keep seeing that type of word problem come again and again.
Why can't we just always just get the half?
Oh, I'll make up a new word problem for you, straight out of grade 11. Okay? 2 times one number plus 3 times the second number is 57. Find the two numbers whose product is a maximum. And then things go completely off the rails, and it doesn't do halfway anymore.
But just divide 57 by 2 and then you get decimal and use that.
It sounds great, and it'll give you the wrong answer. As soon as the situation's asymmetrical, a 2 and a 3, it doesn't work out the way you want it to. So anyways, my shorter answer to that is, it won't always work that it's halfway. Sorry, it won't always work that you'll just be able to take half this number and get the answer. It will be halfway between something, but you won't know what the somethings are until the question continues on. Yeah? I wouldn't lie to you. I'm not making it up. This, Mandalorian. You Mandalorian? No? Not even Mandalorian. This is the way. Can we do another one? Yeah, sure. Let's do another word problem. Joban is building a fence around the beach. He has 16 meters fence to use. It will only have 3 sides. What would the dimensions of the fence be if Joban wants to maximize the area? I could make a table like the previous one. Choose length of 1, what would the width be? Choose length of 2, what would the width be? And do it, and half a page of work, and we'd eventually get the answer. I think you're going to like the geometry ones better. I think. Most people like the geometry ones better. So watch this geometry. He's building a fence around the beach. It will only have 3 sides. What he means by that is it's got water on one side. Yes? He's got some pet seals. When they come on the land, I'm just making up random stuff now. When they come on the land, he wants them fenced in a play area. Yes? He can't control them once they're in the water. I'm just making up something ridiculous to try and set up why this might be true, why you'd want to fence this in. Because you certainly wouldn't use this for your children. You wouldn't use your water as the 4th fence. That would. Anyways, 3 sides. He has 1,600 meters of fence to use. Yes, they can. Yeah, but I can't control the seals. If they want to leave, they're gone. But if they're coming on land, they're not going up to the bar. They're going to stay down here at the beach. Yeah, I know. I can't. It's like kids. I can't control their whole lives. I can do what I can. Yeah? Right. Get ready for me to sort of build the table, actually. You're like, but I don't understand. I want you to build the table so I understand. Okay, I'll sort of build the table here. I have 1,600 meters of fence. Write this really small in your diagram. What if I use 100 here? What if I use 100? What will the other side, what will the far side be then if I use 100? It'll also be 100. And if I use 100 and 100, and I've only got 1,600 meters of fence, what's this one going to be? 1,400. How did you get that? Yeah, he subtracted. He went 16 minus 2 of the 100s. I'm telling you, this is some of the most brilliant mathematics I'm going to teach you this semester is to go, well, what if it's 100? Then do some algebra. Then get out the propane tank, hook up the barbecue, and go, okay. I was sort of ready now. Instead of 100, I want this to be x. And if that side's x, what's this side over here? It's also x. And if those are both x's, this last side, algebraically, is going to be, oh, all my drama's stolen because I wrote the wrong thing here. This was supposed to be 1,600 minus 2 of the 100s. Yes? Back to my dramatic moment. If it's 1,600 minus 2 times 100, and my length instead is x, this is going to be 1,600 minus 2x. That's not easy, but most people find the geometry ones much easier than the number ones. Like, oh, I think I can do that. Put the x on certain sides, and then think out what I do to get that third side. What do you do to get the third side? You take 1,600, and you subtract whatever that is, and you subtract whatever that is. They're both the same, so I'm taking 1,600 minus 2 of whatever x is for you. Question?
Wouldn't the area always be maximized though, no matter what it is? As long as you use up all the fence?
No, it's different areas for all different lengths. Oh, good question. Let me make up 2, just to convince you that based on how I build this rectangle, I'm going to get different stuff. Let's say I do the one I was talking about, and I go 100, 100, and this would be 1,600 minus 2 of the 100s, which is 1,400. And you go, oh, that's the way to go. Someone else goes, no, no, let's go 300 on each side. What will the third side be if those are both 300? 1,000, because he took 1,600 and he subtracted 2 of the 300s. And he uses 1,000 on this side. Who made the most area? Well, this one's 1,400 times 100, which is 14,000,000. 14 million, that area will be. This area, sorry, 114 million. 140,000. Yeah, it says it right there. This one's 300,000. So by using different dimensions, I can get a much bigger area, even though I'm using the same perimeter. Wild, eh? It's sort of like this. Long, skinny ones don't give as much area as wide ones. You get more in the middle the closer you are to the middle as opposed to wide. But it's not exactly in the middle. This is exactly the question we're talking about. It doesn't work out to be exactly in the middle. Go again. Let's build another rectangle. This is a lot like a table that I was building. Walk through it every step of the way with me. I'm building a three-sided rectangle. Let's say I decide to make this 250, this side. What will this side be? 250, because it's a rectangle, so those sides are equal. Now, how do I get this third side? Because I've got a total of 1,600 meters of fence, but I just used 250 over there, and I just used 250 over there. Chris? 1,600, subtract 2 of the 250s. And this would be a different area again. 250 times 1,100 is a different area than either of the ones I got. We want to find the one that gives the most area for my seals.
What if you make it like this?
Oh, yeah. He says, what about a triangle area? Is
No,
that
there's 4 sides. It's just for the time.
Yeah.
N equals 1.
different geometry problem, and we can get to those. Yeah? Maybe it's better, maybe it can't be better. In calculus, we'll prove whether a rectangle or a triangle is the best way to go here.
No, it's a rectangle. It's got 4
Sorry, it's a trapezoid. Okay. A circle's the best way to go. I'll give it away. But to prove that is really difficult, and we'll do stuff like that in calculus. Does this help? Yeah? So, to get the 3 sides, let me say it in words that might help with my algebraic picture. Set this side anything you want. This side will be the same. And this side will be 1,600 minus both of those. Well, that's what my algebra says. My algebra says set that to x, set that one to x, and this one's 1,600 minus 2 of those. Chris?
Would a square give you the largest area of the rectangle?
Not this time. I know you want it to. And I'll be able to explain it at the end. Save your question for the end. When I get the answer and it's not what you expect, get me to clarify. And I'll be able to say something that makes you go, huh. Yeah? Because there is a big idea developing here. Yes? All right. If I want to maximize the area, then I need an equation for area. And what's area of a rectangle? She's a step ahead of me. I was just looking for length times width, and she jumped ahead and said x bracket 1,600 minus 2x. How do I know it's what? How do we know it's not a triangle? You know what? You're not wrong. The question should have been phrased. Is building a rectangular pen. We're much more careful on the test. Like I say, this needed a little editing there. Rectangular pen. You're right. How do I know it's not a triangle when it says 3 sides there, and we don't know that in this question? But I'm telling you, in grade 10, we'll stick to rectangles because anything else gets really, really complicated. Okay, so rectangle. Well, the rest is, I won't say easy, but familiar at least. Multiply it out. And in this case, the terms are in the wrong spots. Which relates to something I said weeks and weeks ago is, why do they give us these equations in the wrong order? Are they trying to mess us up? I'm like, no. Depending on how you do the algebra, the terms will just come out where they come, and it's your job to get them organized and fixed up. Why am I getting random green spots on my screen here? And here comes these familiar steps again. It's not a value 1, so I common factor off the a.
Why did you switch that?
because I want the degree 2 term first. I want, if it's going to be ax squared, I need that first. So I didn't, that line to that line, I didn't really do anything except go put the x squared first. That's what we're used to seeing, right? And then common factor the negative 2 out. Screwing up the half thing, by the way, if you're right with me. Now it's not going to be half. The magic number. Oh, boy. Now we're going the other way, aren't we? Yeah, what's 400 times 400? Yeah, I'll show you a quick way, actually. Negative 800 over 2 squared is negative 400 squared. Here's how you do it. Square the 4, 16. 2 zeros, and then 2 zeros again. Because you're squaring it, you get 2 of the zeros from the first one, and you get 2 of the zeros from the second one. Yeah. Underline the first 3, and look for 2 numbers that multiply to 160,000, but add to negative 800. No, you don't have to do any math. It's there. The number's on the page there somewhere. It's the negative 400, yeah. Therefore, the max area happens when length equals 400 and width equals, ooh, we're going to need someone clever to be able to tell me what the width is, with max area of 320,000 meters squared. Oh, length 400 meters. How do we get the width? After all that, I decided that 400 was the number I should have used. Did I happen to use it? Wouldn't that be funny if I used it? Did I use 400? I used 100, I used 300, I used 250. How long do you think this would have taken to eventually come to the right answer using this playing around method? Maybe a week or so. Yeah? So as long as the algebra is, it's still 10 times faster than doing this by hand. But how do I get the width? Chris? 2 times 400, because I used 400 there. I used 400 there. So this is, I'm going to write it over here, actually. I don't know if this is good form or not, and I don't care in this particular case. I'm just letting you know that's where the width comes from. It's from what we were doing initially. Take the 1600 and subtract the 2 lengths that I had there. And so I get 800. And here, finally, ready for your question, Chris. It's not a square. I have to use as much to go this way as I used to go that way. So I used 800 left, right, and I used 800 up, down. That's a little more complicated than just a square. This was 3-sided. Yeah, you're right. It's half a square. So there is something more to all that. I find those rules to memorize them aren't as helpful as you might think they are, because we're not going with rectangles all the way. Next we're going to go, not here, we're going to go triangles, circles, stuff like that. And suddenly that half stuff doesn't really help all that much anymore. Yeah, but it's fun to look at. Yeah. Again, these are very difficult. I will not lie. These are very difficult, but they're also very repetitive. The same questions happen again and again and again. One more. Do we have enough time? You've been asking great questions, but it has put us in time trouble, and that's a balancing act we'll do. During the summer months, Sarah makes and sells necklaces on the beach. We're back to the beach again. She's selling necklaces to these seals at the beach. Last summer, she sold necklaces for $10 each, and she's averaged 20 sales per day. Considering a price increase, she took a small survey and found that for every $1 increase, she would lose 2 sales per day. All right. We've had 2 warm-up ones where I did the table. And I'll do the table again if we need to. But I'm going to go after the algebra. Here's the algebra, okay? Let x be the number of $1 increases. Okay? We're going to set x to be how much she's going to increase her price. You're like, what if she should decrease her price? It'll work out. I'll get a negative number. Yeah? Maybe she should keep the price the same. We'll get x equals 0. So saying it's going to increase doesn't mean that I'm not going to find out this is a negative number. Therefore, Sarah's new price will be, I need an algebraic expression for what her new price is going to be. Her old price was $10. She's increasing it by x. 10 plus x, okay? 10 plus x. Hopefully, with what we've done so far, you're like, okay, that's okay. Her new number of sales will be, here we go. Last summer, she averaged 20 per day. If she increases the price by $1, she's going to lose 2 sales. Last summer was 20, but now she's losing 2 sales for every time she increases the price by 1. 20 minus 2x. That's good. Yeah? Well, now I need to talk about this word for a second, and if I run out of time, I run out of time, because you need to understand this. Every year on May 2-4 weekend, there's a garage sale in my neighborhood. All the way down. It's popular. Cars, like, it's just always lined up. It's a little bit dangerous, actually, how many cars show up. And every year, one of my daughters, like, because I've had, one of my daughters is 22 and one's 10. So for years, I've had a young daughter. For a long time, for 20 years, I've had a young daughter. And every time they want to run a lemonade stand, and every time I'm like, oh, no. So here's what happens. We go to the store. We buy one of those cute jugs. I buy some lemonade. I buy some ice. I bought some red Solo cups. Gathered it all up. $47 later, we trot home, mix up the lemonade. She puts her ponytails in to be cute, sell lots of lemonade, and she sells a lot of lemonade. Yes? She comes and she says, Dad, look, $100. And I go, well, sort of. And you're thinking, you giant jerk. Did you make her pay for all that stuff? No, I didn't. But there's more to profit than just how much money you bring in. Here, maybe the accountant business people would argue this is the most important equation in the world. Profit equals revenue minus cost. Hey, Mr. Todd. No new words. It's Friday. No new words. Okay, no problem. Money in minus money out. I hope that's not too complicated. A word on a Friday. So my profit will be price per necklace times number of necklaces. That's how much money she's going to make. But then subtract, what does it say? The material for each necklace costs $6 minus cost of necklaces. Here we go. Profit equals. How much is the price per necklace? It's already on the page. 10 plus X. How many necklaces is she going to sell? It's already on the page. 20 minus 2X. Minus $6. She's got to pay for each of these necklaces. $6 times the number of necklaces, which is the 20 minus 2X again. She's got to pay $6 for each of those necklaces. So she gets 10 plus X for each of the necklaces, but she pays $6 for each of the necklaces. Woo! Oh, this says assigned work attached. I'm going to move it up. The assigned work is in your work page, or in your package. Yes, if you flip it over, all the questions are there. Some have equations, some don't. What a great weekend you're going to have. I'm going to do the rest of the algebra reasonably quickly, but then I will pause at the end for any questions you have about the word problem and the algebra. I'm going to say it out loud as I'm doing it, but the algebra is stuff you've all seen before. Multiply out the first bracket.
Oh. I think.
So I multiplied out the brackets. Then I collected like terms. And made a mistake. That was 200 minus 120 plus 80. Common factor out the A. Find that magic number. Half of 6, 3 squared is 9. Okay. Factor and distribute. Vertex answer.
Sorry for the interruption. We have one announcement before lunch. This is just a reminder that today is the last day to buy flowers at the SJC Flower Shop pop-up. We are selling flowers outside of the library during junior and senior lunch. Come buy a treat for a loved one or yourself. Thank you and have a great lunch.
What was the initial price? There. Let me say it again. These word problems are very difficult, but they're very repetitive. If you take my notes, look at the ones in the homework, and chip away at it, you'll be all right. If you don't do any of that homework, here it comes, friends. 3 word problems on the test, all worth 5 marks, 15 marks, right down the toilet before this test even gets rolling. This last-minute strategy that some of you have is just not going to work here. You've got to dedicate some time to this. Yeah? Oh, let's stop that video.